All right, we're going to talk about graphing um, quadratics in vertex form, a different form than when we first started out. There is standard form, which is always the case when it's in standard form. All quadratics can be written like that. There is another form you'll see quadratics. Remember, quadratics just mean when you say that something is a quadratic, you're just saying that the highest power is 2. And so this is a quadratic function as well. It's just in a different form. We call this vertex form. All right. Without going super deep, we looked at this a little earlier when we talked about functions, but this thing right here, for our purposes, in fact, let me use red. For our purposes, this thing right here tells you whether you're going upwards or downwards. If it's a positive, you're going upwards. If it's a negative, you're going downwards. Now, it also does some things with the shrinking. It makes it skinnier and wider, but I'm not overly concerned about that right now. X, you know, is your variable. This thing right here, right? This thing right here tells you to go left or right, right? We'll pick this back up here in a second. I'll show you what I mean in a second. But remember, because it is negative in here, it's the opposite of what you think. And then this thing right here tells you to go up or down. And that's exactly as it is. Now, I just wanted to point those out just as a review, and we're going to go back and look at these things. But when I'm talking about moving it, I'm saying moving it from what we call the parent function. The parent function is f of x is equal to x squared. When it's just straight up x squared, no extra k's, no extra h's, nothing in front, just x squared, this is the function. It has its vertex at 0, 0. When I do this, when I start adding these other pieces, I'm calling this is called a translation or a transformation more generally. If I'm asking you to translate this thing, I'm going to ask you to move it. So starting here, this right here tells me I need to go to the right 2, and this right here is telling me I need to go down 1. So from the vertex, I should move that vertex to the right 2 and then down 1. So if I were to sketch that, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. I start here. But because of my translations, I'm going to move to the right 2 and then go down 1. That's where my new location of my vertex is. So I translated it by moving to the right. Remember, it's the opposite of what's on the inside, and then down 1 on the outside. And from there, just as a sketch, I can just kind of still go up. And I know I should go up because this thing right here is positive. All right. I could ask you to sketch, for example, and let me make one up. Sketch this function when I know that it is negative x plus 1 squared plus 2. Well, if this is my graph, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. I know I'm starting here because that's where my parent function told me to start. So it starts at 0, 0. Now this thing says that I should go to the left 1 and then go up 2. That's what these say. Remember, it's the opposite of what's on the inside, but the exact thing on the outside. So if I start here, I move to the left 1, go up 2. And instead of making my parabola going upwards, remember, this negative tells me I should make it go downwards. Just a sketch. If we want to know the exact values, we can just plug in different values of x to find out what they are, just like we did in the very beginning. If I wanted to know the specific values, I can always just, plug in values of x. That never changes. I can always plug in the value of x. Even when it looks in this format, I can plug in values of x. I bet you if I plugged in a 1 here, I would get a 2 out. All right. For right now, that's all I really wanted to say about that. Yeah, that's it. All right, thanks.